In this video, we're going to cover the second derivative. So the second derivative is the derivative which is the derivative of the derivative, if that makes sense. So we've usually see the first derivative expressed as the following here on this line. All right, but you can differentiate that. And when you do that, you get something we call the second derivative, and you can even keep going to the third and so forth. So you can keep going on until eventually you can't do it anymore. So the same rules apply for normal differentiating a function as they do for finding the second and the third and the fourth, etc. Now, we have done a bit of this in the past videos because remember, if you have an original function, that is what we call as your displacement function. The derivative of that would then be your velocity function, and then your second derivative is your acceleration function. So here we have find the first four derivatives of the following. So if we find the first derivative, the 4 comes out the front, so 4 times 4 is 16x to the power of 3. Minus 3 comes out the front, so 2 times 3 is 6x squared. Because it's only an x by itself, that becomes 5. And because there's no x with the 3, it disappears. So if we do it again, we'll find our second derivative. The 3 comes out the front. We get 48x squared minus 12x, and then the 5 disappears. We could then do our third derivative. 2 comes out the front. So we get 2 times 48. And then we get minus 12. And then lastly, we'll do the last one, our fourth derivative. We get 96. All right. Find the first and second derivatives of the following. So if we say fx equals x minus 4, our derivative minus 4 comes out the front. And then we minus 1 off, so that becomes minus 5. We then go and find our second derivative. Minus 5 comes out, so minus 4 times minus 5. And then we take 1 off. Because the original question gave it to us as an index form, we will leave it as an index form there, like negative 6. Now, the key to this question is that they have this here already. Now remember, this is velocity. And we know velocity is already dy dx. So that means we're only asked to find the derivative of this function here. We don't have to do it twice, which may be misinterpreted by looking at that. So because we've got bracketed area times bracket, we know we're using the product rule. So I'm going to write v equals x plus 3. 2x minus 1 squared. Now, for the sake to make this a little bit easier in the terms of how we've done the product rule in the past, I'm actually going to change that v to a y dash, all right, a y apostrophe. Now, if we do this now, we can focus on, we know we have u, which is my x plus 3. And we have v, which is 2x minus 1. Now we're going to use the chain rule here. So the trick, remember, is to differentiate what's on the inside of the bracket. So if I differentiate just the 2x minus 1, we get 2. And then we look at it as a whole and differentiate the whole thing. So the 2 comes out the front, so times 2. And then we add our bracketed area on the back. All right, and now that'll be a 1 there, but we don't necessarily need the 1. So we end up with 4 bracket 2x minus 1. Now remember, in this case, dy dx equals uv plus vu. But essentially, these are going to be squared because we're finding our second derivative this time. So x plus 3 times that plus times that. Alright, technically we can factorize this out, simplify it, sorry, because we have common terms here. So we'll get 2x minus 1 x plus 3 plus 2x minus 1. And we can just leave it as that. So to end the video, we'll do a quick recap. Now remember, it is possible to just keep differentiating a function. So we have the first derivative, the second derivative, the third derivative, and so forth. A little thing to remember is, remember your original function is displacement. First derivative is velocity. Second derivative is acceleration.